Right, welcome to the solution to exercise 8-12, located on page 363. Walton Limited is considering replacing an existing machine with a newer and faster machine that's going to produce a more reliable product. This will allow them to increase the selling price for the product. Switch is going to increase fixed costs but not variable costs. Cost and revenue information is as follows. Okay. Required, number 1, determine the break-even point in units for the two machines. Alright, so, well, let's see. We know the formula is fixed cost divided by contribution margin, so let's work out the old contribution margin, which is going to be selling price minus variable costs. And so we have the selling price of $36 minus the variable cost of $28 gives us a contribution margin of 8. So the monthly fixed costs of $240,000 divided by our contribution margin per unit of 8 gives us a break even of 30,000 units. That's for the old machine. The new, again, selling price minus variable costs is 40 minus 28 equals 12 per unit. It doesn't look very 12-ish. That's 12. And therefore, fixed costs of 500,000 divided by contribution margin of 12 gives us a break even of 41,666 and 2/3, but you can't have 2/3 of a product, so we're going to call it 667 units. There. Okay. So that was number 1. Number 2, determine the units the sales level at which the new machine will achieve a 10% target profit to sales ratio. Okay. So if we have a profit to sales ratio of 10%, that means that if the selling price is $40, then the profit has to be 4. So we can pretend the profit is a variable cost, right? Profit per unit, because they'll go, they move the same, they're both variable. In which case, at a selling price of 40 minus the variable cost of 28 and the target profit of 4 per unit means we end up with a number of 8, and therefore we need 500,000 divided by 8, or 62,500 units in order to achieve a profit that is equal to 10% of our sales. So this one's a little bit tricky. We normally think of target profit in terms of dollar amounts, which is why we add it to the fixed cost, because it's fixed. If you want an X dollar amount, it ain't going to move, right? It's X dollars. But this problem asks for X dollars per or a percentage, which in effect is a per unit basis, which is kind of sneaky. Anyway, so let's look at number 3 now. Determine the sales level at which profits will be the same for either the old or the new machine. Okay. So if they're going to be the same, we're going to set up an equation. And so what's the variable going to be? Well, the variable is going to be the number of sales, right? Because that's what we're trying to figure out. What's the level of sales? So that can be X. Sales in units. Okay, so then the old machine has a contribution margin of 8, and this is all about profit. So profit on the old equals profit on the new, right? But profit equals sales minus expenses, or sales minus variable costs minus fixed costs, or contribution margin minus fixed costs, total contribution margin now, right? So if we think along those lines, the total contribution margin for the old machine was $8 per unit times level of sales minus the fixed cost for the old one, which was $240,000. And then the contribution margin for the new one was $12 per unit, but it had much larger fixed costs. Okay, so if we net our fixed costs here, basically add 500,000 to both sides, that now becomes plus 260,000 equals 12x. And if we subtract 8x from both sides, we get 260,000 equal 4x. Divide by 4, and we get x equals 65,000 units. Okay, last one, number 4. Which machine represents a lower risk if demand is uncertain? Explain. Okay, so the way this works is if demand is uncertain, then we will assume that means it's going to be volatile. Could go up a lot, could go down a lot. And so in a case like that, the old machine with its lower fixed costs is going to produce, or going to be less risky if you think of risk in terms of which one has the greater capacity to go wrong. And that's simply because at a lower level of demand, you will break even with the old machine. The new machine breaks even at a higher level of demand and is more profitable per unit beyond that, right? Because it's got a higher contribution margin. But when you don't know what demand is, you're perhaps going to be inclined to play it safe, give up a little bit of that potential extra profit in return for a lower break even with the old machine. So to quote the solution, this is an example of operating leverage. For every unit shy of the break-even point, the new machine results in a greater loss per unit, and for every unit past the break-even point, the new machine results in a greater profit per unit. Also notice that the break-even point is higher with the new machine than the old machine. And that, well, here, we'll write it down. The old machine has lower fixed costs and lower break even. So therefore, the old machine is the one that you want. And really the break even is in this case probably the key. And that concludes the